So if you could gather your attention. Theorem 5.8 says, if two lines are parallel, then all points on one line are equidistant from the other line. Yes. And
heads up. Pay attention. Hey, man up. All these people. Dude, did I ever go on? Most things Whoa, Dad.
all points on one line are equidistant from the other line. So with 2 points on this line, what my job is to do is say that these 2 points that are on line T are both the same distance from line L. That's what I need to show. The way you measure the distance from a point to a line is with a perpendicular segment. So we are going to construct perpendicular segments. And what I know is that these lines are parallel. That's my given information.
That's key now.
It is. We'll go ahead and call this point A and this point B, and then where that perpendicular intersects line L, X and Y.
Yes, you did.
So we are also going to be given.
This one, focus. We're talking about that.
Yeah, but if you could just focus, please, then they will not be distracting me.
I'm good. I'm sorry. She started it.
No, the title of the line is actually always lowercase. Okay. So now, what we are also given is that segment AX is perpendicular to line L, and segment BY is perpendicular to line L, because that's how you do distance. So we have AX is perpendicular to XY, I guess. And BY is perpendicular to XY. XY. I know it. Guys, gather your attention, please. These recordings are going to be full of, if you could gather your attention, please. Exactly. So, whoever watches them has to listen to that too. So, Bar,
Shut up.
You could gather your attention, please. All right. Now, we're going to be proving that AX is congruent to BY. Or that any point on line T is equidistant to line L. Do we have a parallelogram? We do. Why? Why is it a parallelogram? Because these lines will have to be parallel if they're both perpendicular to the same line. So first off, AX will be parallel to BY because both are perpendicular to XY. The theorem says that two lines are perpendicular to the same line in a plane, then they are parallel. And what this means is ABYX is a parallelogram by definition of parallelogram. Since it's a parallelogram, opposite sides have to be congruent. By Theorem 5.1, opposite sides of a parallelogram are congruent. So I can prove AX is congruent to BY by Theorem 5.1. Theorem 5.9 now. If we have three parallel lines that cut off congruent segments in one transversal, then they will cut off congruent segments in every transversal. Yes, it is. Cut off. Congruent segments in one transversal.
What's that? Lines.
Thank you.
Lines.
Cut off congruent segments in one transversal. Then they will cut off congruent segments in every transversal. So here's our diagram. We have three parallel lines. And we have a transversal that has segments that are cut off congruently. What I need now is another transversal. This transversal could be at any angle. We will not. So this transversal could be at any angle, and if it crosses those three lines, it will also be cut into congruent pieces because those lines are parallel. So, parallel lines, and labeling A, B, C, D, E, F are given information is that A, D, B, E, and C, F are all parallel. Taking notes because I keep you talking. Also given A, B, and B, C are congruent. Then what we want to prove is that DE and EF are congruent. In order to get there, what we are going to want to do is show that we have some parallelograms, which means I need some auxiliary lines. I am going to have, first up, a line that's parallel to AB that goes through E. So, I have here some lines that are parallel. I'm going to also need a line that is parallel to BC that goes through F. So, I should put 2 arrows on these. Let me ask you, will, and I'll call these points X and Y where they intersect those other lines, will XE be parallel to YF? Since XE is parallel to AB and YF is parallel to BC, will XE and YF be parallel to each other? Yes, they will. Do we have some parallelograms? Yeah. So what I know is opposite sides of parallelograms are congruent, which means I'm going to be able to state that XE and YF are also congruent. Do we have some congruent angles since we have parallel lines? Yeah, we do. Fact is, this blue transversal of lines XE and YF have some corresponding angles that must be congruent, that are parts of those triangles. We're going to look for some more congruent angles, and then we can prove that these two triangles, YEF and XDE, are congruent. Well, we have some alternate interior angles, don't we? And these black lines are parallel. So those alternate interior angles are congruent, and the green lines are parallel, so these alternate interior angles are congruent. Yes, it is. Yep. And also, I have more corresponding angles here. Why not work with them? Angles 1 and 2 are corresponding angles with the black lines and that transversal. If I can prove that these two triangles, XDE and YEF, are congruent, then I will get what I want to prove down here, right? That DE is congruent to EF. I have angle side angle, or I have angle angle side. I have both of them. Okay, so that's where we're aiming in our proof. Let's go ahead and write a proof. Okay, so first off, when we draw XE parallel to AB, I have to explain what my auxiliary lines are, so I'm not going to know that. And YF parallel to BC. And I'll just say parallel to AB at the same time. We form parallelograms ABEX and BCFY. In those parallelograms, AB is congruent to XE and BC is congruent to YF. because opposite sides of parallelograms are congruent. Now, since we have parallel lines, we have some congruent angles.
Holy crap! Not okay.
No, I'm keeping that thing. Give it. Do it at my face.
Should I do it between you to not hit you?
Yeah. You intended it to be my face, so.
Okay.
Where you go?
Since we have parallel lines, we have congruent angles. Which means we can prove triangles congruent. Let's talk about the angles that are congruent. I think I'm going to go with angle YFE and XED.
Oh, are we recording this right now?
Yes, we are.
Oh, sweet.
Maybe you're watching. I have forgotten.
Oh, I hate to see your setup today.
And angle 1 is congruent to angle 2, both of them because corresponding angles of parallel lines are congruent. So the triangles must be congruent by angle, side. No, corresponding angles of parallel lines. This is actually postulate 10. You want to give a postulate number. Now, we have congruent triangles by angle, side. Triangle XED is congruent to triangle, and I'll go back up here and look at it. XED is YFE. By angle, side. Finally, because DE and EF are corresponding parts of these congruent triangles, we can say they are congruent, which proves what we want to prove.
Huh? Oh.
All right, we're on theorem 510.
I don't want that present. Three and 511.
Yeah, I think we probably will only get through 510. 511 is simply 59 and 510 put together. 511 is pretty easy to prove, but we're not going to get them. Okay. 510, a line that contains the midpoint of one side of a triangle, Ransom, and it's parallel to another side, Dustin, passes through the midpoint of the third side. So our diagram here. So our diagram here is going to have a triangle with a line passing through the midpoint of one side and parallel to another side. So labeling what we have given is that we have D as a midpoint of AB and DE is parallel to AC. What I want to prove is that E is the midpoint of BC. So now, what we are working with here is really just a direct result. You guys don't quit talking. Then I will never record again. Now, I think recording is a good idea. But if it means that when I'm recording, you guys will be talking, because you think that I'm not going to stop and get after you, then we just won't record because it's not worth it to me to have you guys not paying attention because I can't stop and just plain scold you. I try to get after you without scolding you by giving you that look. You know what the look means? And as soon as I start writing again, you start talking again. Pay attention, or else we just won't record. And I think recording is a good idea. If you were gone, wouldn't it be nice to be able to look at the recording? I think it would be, but maybe it's not. Maybe we just won't do it. Let me try. This really is a direct result of the last theorem. It almost could be a corollary because all I need is an auxiliary line, and immediately this happens. When I draw that line through B that's parallel to the other lines, you see how you have three parallel lines that cut one transversal congruently. So, as a direct result of theorem 5.9, it must cut this other transversal congruently. So when we draw a line through B parallel to DE and AC, immediately by theorem 5.9, DE must be congruent to BC. You can go to lunch.
No.